Okay, for Core 1, today we started the new unit, Unit 6, which is a unit on geometry. Our learning objective today was just refreshing our memory on all the different shapes we know and their properties, being able to define and categorize the different geometric figures. Now, to do this, we started off with triangles. There are 3 different triangles that we focus on. Okay. There is the scalene triangle, the isosceles triangle, and the equilateral triangle. Now, the scalene triangle has no equal sides or angles. The isosceles has 2 equal sides and angles. And the equilateral is all equal sides and angles. Now, we wanted to look at the definition of them as well as look at one that's actually been constructed. So, let's go ahead and take a look at constructing the scalene, the isosceles, and the equilateral triangles. So first of all, a scalene, no equal sides or angles, not too hard to construct. So, there is a scalene triangle. However, given that I did it by hand with a straight edge, it may or may not look exactly right, so what we want to do is mark it up. Now, putting dashes tells the reader that none of the sides on that triangle are equal. Do the same thing on the angles, and it tells the reader that none of the angles are equal. All right, isosceles triangle. Go ahead and construct that using my ruler, my straight edge. There we go. So there's my isosceles triangle. Once again, I want to mark it up to show which sides are equal. 1 dash on each of those tells the reader that those are equal. 2 dashes down there says that that one is not equal to either of the others. Now I want to mark up the angles as well. So isosceles has 2 equal sides and angles. We have our 2 equal sides. We have our 2 equal angles. Equilateral triangle. I'll draw one over here to the right. Has all equal sides and angles, so I'll do my best constructing one of those. Now, all equal sides and angles means we have 1 dash, 1 dash, 1 dash, 1 dash, 1 dash, 1 dash. That tells the reader that all sides are equal, all angles are equal. Now, a bonus with equilateral triangles, if all angles are equal, it means we are dividing the 180 degrees that make up a triangle into 3. Which means we get 60 degrees on each angle. This works no matter what the triangle is. Now, from there, we moved on to talk about the different polygons we know. First of all, the definition of a polygon. is a closed shape with all straight sides. A closed shape with all straight sides. Now, closed versus open. Most of the shapes you've seen are closed, such as that one. That one is a closed shape. This would be an example of an open shape, a shape that does not close. So a closed shape with all equal sides. Now, we went through a list of all the common names for different polygons. We have triangle, quadrilateral, pentagon, hexagon, septagon, octagon, nonagon, and decagon. Now, this is an order as far as a 3-sided figure, 4-sided, 5-sided, 6-sided, 7-sided, 8-sided, 9-sided, and a 10-sided figure. Now, there are names for shapes beyond 10-sided, but generally we don't much worry about those. If it gets too large, we just call it an n-gon, which means 27-gon, 98-gon, however many sides you need. Now, one last thing we need to worry about is if it is a convex versus a non-convex polygon. So here's the difference. Once again, a convex polygon is similar to polygons you've seen. So there's the simple pentagon. A non-convex means it's caved in somewhere. It is also called a concave polygon. Mostly we deal with convex polygons, but occasionally we will see the non-convex or the concave polygons. Now, let's talk about the quadrilaterals that we're going to focus on. Normally we will focus on triangles or quadrilaterals. And just like how we looked at scalene, isosceles, and equilateral, we are going to look at the special quadrilaterals, at least a decent sized list. So we have squares, rectangles, parallelograms, and yep, I just misspelled parallelograms. Parallelograms, kites, rhombus or rhombi, as I believe is the plural, and trapezoids. Now, let's start with the simple one. So a square. Obviously, we know what a square is. A square has 4 equal sides and 4 equal angles. Now, drawing a square by hand like this, it's not going to look perfect, but it's going to look good enough. Now we just finish it up, just like we did our notations on the triangles. All the sides are equal, and all the angles are equal. Now, once again, if all angles are equal, first of all, 4-sided figure angles add up to 360. If we divide that by 4 equal angles, we get 90. So all those angles are 90 degrees. Next up, rectangles. Pretty much the same thing as a square, however, it's been stretched out. So I'll make a rectangle here. Doing my best to keep it as much as a rectangle as I can. So there's a rectangle. Now, all four sides are not equal. We have one set of equal sides and two sets of equal sides. However, all angles are still equal. Therefore, all angles are 90 degrees. Now, parallelograms are similar to rectangles, but they are squished and slanted. So I'll go ahead and take my rectangle and slant it a bit. And there we have a parallelogram. Now, parallelograms, once again, are just like rectangles. They have two sets of parallel sides. However, not all angles are equal. The opposite angles are equal. And I am also going to notate that we have 1 and 2 sets of parallel sides. The arrow will denote if something is parallel to something else with a single or a double arrow. Now, a little less known is a kite. However, it looks just like a kite you might imagine that's flying up in the sky. Looks like a diamond that has an oblong side. So there's our kite. Now with a kite, we have 1, 2 sets of equal sides. We also have a pair of equal angles, and then 2 angles that are not equal to anything else. Also, in this case, nothing is parallel. Now, a rhombus. A rhombus is much like a square that's been skewed and tilted. The rhombus, or rhombi, have 4 equal sides, but not 4 equal angles. So we have 1, 2, 3, 4 equal sides. We have those equal angles, and then those equal angles. Last up, trapezoid. Trapezoid has a pair of parallel sides, one on top of the other, or side by side, depending on how you're drawing it. So we started with parallel sides. But that's pretty much all we know. After that, we have 1, 2, 3, 4 different side lengths, and 1, 2, 3, 4 different angle measurements. So trapezoid has nothing else in common except for those 2 parallel sides. All right, that was it for the main topics of today's lesson. Please make sure you watch this a couple times and or make sure you take good notes. And we'll hopefully see you tomorrow.